This is a F-150 remote control car. I got it for 30 bucks at Walmart, and I'm going to modify it to be a smart robot car. First thing we're going to do is we're going to charge the battery. So definitely after you get it out of the box, first thing to do, you see the contacts here for the battery. So you slide this in. It's important to note, let's see, yeah, so you slide it in, it kind of latches in place, and it's ready to charge. So we'll get that charging. So you need a few more parts for this. One of the things we're going to use is this LM298 motor controller board. I may try to see if I can steal a motor controller that's in there, and then we could avoid using this, but these are cheap. These are like $3 on eBay, and they're good motor controllers. The brain will be this computer card called PSOC4. I actually have several options here. This is the PSOC4 Pioneer Kit board. These are about $25. Another option is this -043 PSOC prototyping kit. You can see with this one, it has really more convenient connectors and things. You USB connect it to your computer and program it through there, and you wire up to these connectors. But with this prototyping kit, you can see it's smaller. It does not have the same connectors or so on, but it has the same pins technically as this board does. This is 25 bucks, this is 10 bucks. And you plug it into the USB port on your computer and you program it through this chip, and then if you want you can break that off. There is one more less expensive option. This is technically the same thing. It's compatible. There are some differences, but you can see fewer pins, but we don't need that many. This is $4. So Cypress really makes the price point scalable, which is pretty cool. The challenge with this $4 board is that you can't program it through this connector here. You actually have to snap off one of these, put a connector on it, and then plug it into these 5 pins here, and then you program it using this little programmer chip. So even though this is $4, it's hard to program. You at least have to at first buy the $10 kit to get the programmer. So this seems to be the way to go if you're open to soldering and you want a less expensive option. And then this requires less soldering, probably no soldering. So we'll take a look at how we do that with each of these as we go along. The other thing I want to do is eventually put some sensors on here and turn this into basically a obstacle avoidance car. So, you know, we put one here, put one here, one on the other side, and then this can avoid obstacles, which is pretty cool. And the fact that we're using this PSOC, the reason why I want to try this is because this allows you to do that all in hardware. So there's no software running, there's no operating system running like on the Raspberry Pi, there's no C code like on the Arduino, but you can put C code in here, and we probably will have to do that for some of the hardware functions. But it will take a minimal amount of software And the nice thing about doing this all in hardware is that it's extremely fast. So everything happens on a clock cycle, a very fast clock cycle, and technically you can run this car full speed and have it stop on a dime. And so we're going to see how that works. The other thing I've found with these smart robot car obstacle avoidance cars is that the ultrasonic sensors don't do a good job of detecting chair legs or table legs. In fact, they don't do it at all. They do a very, very poor job of it. So I'm going to use this little micro switch here. This is basically a switch. When the switch goes down, it makes contact. When it goes up, it's open. So we're going to put that switch right on the front here so that when this thing, when it runs into something with this front bumper here, it'll press the switch and the computer board will know, I ran into something. So that's kind of a last resort. And then one more fun thing, always fun to have some LEDs and stuff. So I've got some of these cool LEDs and put one of those in there.